Hello students. Today we'll be discussing pseudo force. Okay. So before that, let us discuss something else. Have you ever noticed when you are in an accelerating car or in an accelerating train, you feel a pushback while you are sitting on the seat. You feel a pushback, or maybe when the car is stopping, you feel that you are falling forward. Okay. Why does that happen, right? So from the childhood you have heard that this is because of inertia. But is that very clear to us? What does the sudden force coming from? No, right? With this topic, we'll be trying to understand the mechanism behind this force. Where does this force coming from? What is this force? Okay, what is the origin of this force? So we'll try to understand that. For that, let us understand. Let us take a scenario. Let's say you are standing on ground. All right. Now, let's say a slab of mass m is also kept on ground, and another small block of mass small m is also kept on the bigger slab. Now, imagine you are pulling, not you maybe, this slab is being pulled with some force F. So what will happen? This slab will start moving forward with some acceleration. How much is that acceleration? That acceleration would be force divided by the mass. Alright. Now, we are not very much concerned about what will happen to this slab. We are more concerned about what will happen to the smaller block. So, there is no force on the smaller block, right? Only gravity is acting upon it. Any other force? No. There is no friction. So, what will happen? This slab will move forward just like this, and the smaller block will fall on the ground without making any displacement in this direction, right? All right, that's quite fine, right? We don't have any force in this direction, in this dimension, so no acceleration, no displacement, fine. Now let us assume that you are actually standing on this slab. You are standing on this slab. Again the same thing, and let us assume you are massless. For simplicity, let us assume you are massless, you are standing on this slab. Again the same force is acting upon it. So what will happen? You with the slab will move forward just like that, and the smaller one will fall down. Now what did you see? Okay, if I am here, I can see the exactly same thing happening what happened before. But let's look at it from your perspective. You were here, the slab was here, and the block was here. From your perspective, you did not go forward. From your perspective, the smaller mass went backward, right? How did that happen? Because for this block to get backward, there should be some force acting upon it, at least from your perspective. Maybe not from everyone's perspective, but at least from your perspective, there should be some force acting upon it. That's why there is a relative velocity between, relative acceleration between you and this block. What is that force? That force is precisely the force you feel when you are in an accelerating car. That force is pseudo force. We call it pseudo force. Why is it pseudo force? Because this force primarily depends upon from where you are looking at. If you are looking at this scenario from the ground, it's completely fine. There is no extra force, nothing like that. But the moment you are looking at this scenario from, or from the moving accelerating frame, the scenario changes, the force appears, and this is called the pseudo force. How much is it exactly? Okay, how much is it? Let us try to find out how much is it. So the slab is moving with acceleration a. You are also moving with acceleration a. And from your perspective, the slab is moving with acceleration minus a. Right? So how much is the force? Force is equal to minus a, which is the acceleration multiplied with the mass of this slab. So how much is it? Mass into acceleration. In which direction? In the opposite direction of the actual acceleration of the frame. And this is, my friend, is known as pseudo force. I hope it's clear to everyone. We can look at few, at least one example, and see how to apply this topic, this concept into actual numerical problems. So let us assume a question where they're saying find the angle a simple pendulum is making with the horizontal when kept in a accelerating car or train. Taking everything standard, mass is m, acceleration a, length is l. So let us try to draw how the pendulum would be in an accelerating frame. The pendulum in a non-accelerating frame would be like this. This is hanging. But when it is in an accelerating frame, maybe if this is accelerating with A, the pendulum will actually look like this. We'll be making some angle theta with the vertical. Also, let's take angle theta with the horizontal, as it has been asked in the question. Now, for that, let us make the free body diagram of the bob. Gravity will be acting downward. The tension will be acting along the string, and there is one force, pseudo force, opposite of the acceleration, that is ma. Now let us break the tension into components. If this is theta, so T cos theta, T sin theta. Now as it is at equilibrium, all the forces will cancel each other. So T cos theta is equal to ma, that's equation number 1. T sin theta equal to mg, that's equation number 2. And if we divide question number 2 with equation number 1, what we get? We get T sine theta divided by T cos theta, that is equal to mg divided by ma. So tan theta is equal to g by a, or theta equal to tan inverse g by a. So that's the answer. So now you know how to apply the concept of pseudo force in a numerical problem. Thank you.